Thank you for that lovely introduction and the opportunity to be here. I'm Dr. Sanna Gaspard. I have a doctorate in biomedical engineering with a specialization in medical device development and commercialization. From the age of 20, I've invented, at this point, maybe just 3 medical devices, ranging from robotic infant massaging devices to carotid artery stenting mechanical systems and delivery systems to now optical skin sensing systems. Today I'm going to share my personal journey from coming from a small island in the Caribbean to now becoming a health tech entrepreneur in the biomedical space and in the wound care space. So I'm originally from the island of St. Lucia, which is a very tiny island in the Caribbean. If you were looking at it on the map, it looks like a dot. When I was a child in my formative years, it's still considered a developing country, but it was even more so then, which means that we didn't always have access to all the resources we needed. If you needed to fix your car, or if you needed medicine, it wasn't always readily available. So it was a community where people had to identify their problems on their own and come up with their own solutions. And a lot of people did that with an entrepreneurial spirit. It was an environment where, for example, if you needed medicine, you would look to natural solutions. So for example, if you were constipated, you might make some tea from senna pods. If you wanted to whiten your teeth at the time, you would use charcoal instead of going and buying toothpaste because people couldn't afford it. And if you had inflammation, you might make some dandelion tea to help reduce the inflammation in your body. Growing up in this kind of environment, which was resource scarce at the time, cultivated in me as a child a spirit of creativity, curiosity, an ability to identify problems, as well as to develop need-based solutions. Not just to develop a solution for the need of a solution, but to actually solve a real problem. So as I eventually immigrated to America, started school, finished high school, I started to consider, what do I want to do for my future career? I didn't have any idea. What I asked myself is, what do I want to be? I didn't have an idea. I had like 3 or 4 things I wanted to be. I wanted to be a doctor, I wanted to make things. I just wanted to have a good life, right? As from a family immigrating to America. But I didn't know what that looked like as a job. So instead I asked myself, what would I like to do? What do I like to do? What brings me joy? Right? So then I sat and thought about that, and I thought, I like sciences, I like making things, I like problem solving, and I like babies. That's partly because I'm a girl, but I like babies. And I thought to myself, how can I combine these 4 things into a career? So I would have a career where I was working and happy at the same time. So at the time, I basically went to the library, looked for a career that combined all these things. In terms of making things, I found that that was essentially called an engineer. Then I found for sciences, there was something called biology and the biosciences. And then for problem solving and babies, I saw that was in healthcare. So when I can look for a career that combined them all together, I got a biomedical engineer, and then I realized as a biomedical engineer, I could also be pre-med. So I could still add in the babies and the doctor, as a doctor, right? So with that in mind, I went to undergrad at the University of Miami, and given that I had this passion for infants, and I wanted to be a neonatologist, I started to do research on preterm infants, and looking at what could be done to help improve their survival rate. As I was doing that, I realized in the research we were doing that they found that infant massage could save these infants' lives. However, to do that effectively, you had to give the massage 3 times a day for 15 minutes for 2 weeks to see a noticeable increase in their health as well as in their weight that would allow them to go home early. Looking at that as an engineer, I was at that point majoring in biomedical engineering. I thought, here we have uncovered a physiological therapy that can work on babies, that can help save lives, but it will never get any market traction because it's too time consuming, it's going to require a trained nurse, and hospitals just can't afford it. So with that in mind, I invented my first medical device, which was a smart infant physiotherapy device. Essentially, today you would call it a smart device, but essentially it's a massaging system that monitors the infant's biofeedback system to then automatically provide the appropriate massage for each infant to ensure that they're getting the appropriate pressure to elicit the positive physiological response. And so you would put the baby in there, it would provide the massage, it would monitor their biosignals, so their heart rate, their breathing, their facial cues that usually nurses monitor to identify pain. Because remember, they can't talk. They can't tell you, I'm in pain, you're applying too much pressure, you might break a bone, their skin is very fragile. So you have to be very careful about the amount of pressure you apply, and it can't be a pressure that tickles them, because that actually causes the opposite effect of causing inflammation. Right, so it really needs to be a very specific amount of pressure, and that differs by each infant. So I invented a system that would allow you to provide the appropriate amount of pressure for each specific infant, and then allow you to do that in a cost-effective way that you could potentially integrate this into a NICU, place the infant in there, allow them to fall asleep, and then put the next baby in as needed. So with that invention in mind, I basically graduated out of undergrad and went to grad school at Carnegie Mellon University, where I went on to take on my next challenge. I decided at that point I didn't want to go to med school, so I went to graduate school to get my PhD in biomedical engineering, again with a focus on medical device development. So first going through my master's program, I first came upon the issues with cardiovascular stenting. I'm sure most of you guys are not familiar with that process, but it's essentially, as people get older, plaque builds up in your arteries. Eventually, that plaque, as you can see in the second picture, limits the amount of blood flow that can go to your brain. And as the blood pressure gets higher, some of that plaque can break off, go into your brain, and cause a stroke and kill you. As the doctors identify this problem, the treatment is to put a balloon in there that can expand and remove the plaque, and allow blood flow to go back in and put in a stent. However, the problem with this procedure is that the deployment of the balloon actually releases plaque that can then go into your brain and cause a stroke during the procedure, right? The second issue that you can have, essentially, is that the filter itself, once it's deployed, actually stops blood flow to your brain during the procedure. So you could die on the table in two different ways, just from getting treatment for a condition that could kill you, right? So I came in there and thought, okay, we can definitely solve this problem with technology. We need a better delivery system and a better filtration system that will still allow blood flow to the brain during the procedure without getting clogged immediately. So with that, I went and started to look at what's the problem with the existing filters on the market. So the problem was pore size. As you can see, this has a pretty uniform pore size. So as you get big pieces of plaque that go into this filter, the filter gets immediately blocked, and then the person no longer has blood flow to the brain. In addition, when trying to deploy this filter, the deployment of the filter itself could dislodge plaque from the walls of your artery, which means during the procedure, as they're deploying the filter, that could release plaque that goes into your brain and causes a stroke during the procedure. So there were several issues with the whole procedure, and it came down to the use of the instruments. So understanding these problems and talking to vascular surgeons, I invented the dual net filtration system, which is actually a combination of a new delivery system combined with a new basket and filter design. So it contains a 2-filter filtration with multiple pore sizes and also multiple compartments to keep the plaque from accumulating at the center point. And we invented a new delivery method that would allow you to pass the filter over the wire to the brain with a minimal profile so that you wouldn't dislodge plaque in the artery and have it go to the brain. Right, so it solved all of the problems. There were multiple pore sizes, so the basket wouldn't fill up right away. Let me take it off.
You can take your mask off, yeah.
Oh, okay, sorry. Can you hear me better now?
Yeah.
Okay, sorry. You guys should have told me earlier. Okay, so we invented the dual net filtration system. It has multiple pore sizes in different compartments so that we can catch different sizes of plaque as it's released from your artery. So in this way, we solve the problem with the basket getting closed from large pieces of plaque, because the larger pieces could go through, and then there was a smaller filtration system that would catch them in the second basket. So the opportunity for the basket to get filled and close off all blood flow to the is reduced significantly. And because we were able to then also combine that with, at the time, some nitinol wire, we ensured that that basket, when released, would conform to your artery to minimize the loss of plaque around the filter, right? And then we also invented a new wire delivery system for that. So after doing this, I tried to get a patent on this. It was patentable, but I couldn't afford the patent at the time. And the university basically was like, well, you did most of this in your head, so we can't own it. You have to pay for the patent. And I was like, I'm a poor grad student, sorry. I can't pay for it. So it just became my master's thesis. At that point, I then went on to pursue my PhD, again with a focus in biomedical engineering. But at this time, I was really focused on making sure my PhD was more than just a book that nobody would want to read, including myself. And I was like, if I'm going to devote another 4 to 5 years of my life on a project, I wanted it to have impact on real world healthcare, right? And so with that, I started working on a solution for skin health assessment that I eventually translated out of the university in a startup called Rubitection. So Rubitection is working on developing an early skin health and monitoring care system. I initially found out and learned about this system through an engineering class that I took at Carnegie Mellon. And I developed a solution to really improve patients' access to care, reduce the cost, and also to help save the lives of vulnerable patients. In this case, for example, like Superman, or better known actor Christopher Reeves. So he was paralyzed from his neck down after falling off his horse. He survived for 9 years, thanks to the best healthcare he could afford as a celebrity, until he developed a severe bedsore that was so severe you could see all the way down to his bone that it would take his life. Early detection could have saved his life. Imagine that, right? And he's not alone, because bedsores affect 2.3 million people every year, killing 60,000 of them needlessly. This is because if you can detect the condition early, you can prevent it from developing. But early detection is actually very difficult. The early diagnostic test is manual and unreliable. Whenever you've gone to the doctor and you see them poking your skin, that's basically the test. It's affected by the lighting in the room, or even the color of your skin, independent of your race. On darker skin patients, you just can't see those skin color changes that are associated with inflammation, putting people of color, as I mentioned, at over 2 times higher risk of developing the most fatal, severe cases of the condition, while costing the US healthcare system $11 billion in 1 year alone. Now, right now, this is a condition that can really affect anyone with limited mobility, from children to the elderly. But however, right now, most of the people with limited mobility are the elderly. And just to give you a concept of how quickly this condition can develop, if you've ever had a long day at work and your butt was hurting at the end of that day, you were in the process of developing a bedsore. That's how quickly it can develop. The difference between you and Christopher Reeves was that you were able to get up, allow blood flow to come back to that site, allow the inflammation to decrease, and allow your tissue to restore its health, right? So with the at-risk population generally being the elderly, reaching 80 million by the year 2040, this is soon going to be an avalanche of cost for the US healthcare system and healthcare systems around the world, as well as a huge healthcare problem for families. And what clinicians are currently looking for is a solution that can be low cost, easy to use, and easy to clean, whether you're a healthcare professional or a consumer in their home caring for their elderly parent or a disabled child. So with that in mind, I invented the Rubitect Assessment System. It's an optical device that allows any user to measure the early signs of inflammation in the skin. What we are essentially doing is taking objective measurements of that blanch test that you saw before the clinical standard. So here, for example, is when the skin is red, you push on it and your skin goes white and it comes back. So we're already able to make those measurements, and we're able to make them on white skin, Asian skin, as well as on African skin, on all skin tones, right? Once we get that signal, we then process it with our proprietary algorithms to provide risk analytics, to provide risk analytics about where the condition is currently, to support care management, and support telehealth when used in a home care setting, allowing any caregiver, whether they are a trained professional in a hospital or nursing home, or a consumer like yourself, to have the data they need to save lives, save time, and save money, while allowing, competition on the market, we saw that the solutions that range from ultrasound to temperature sensing, electrical sensing, pressure sensing, as well as position sensing. But none of these solutions were actually addressing the real problem, something that was diagnostic, that was low in cost, and easy to use. You can see most of the solutions are very expensive, and they're also not very easy to use by a consumer. So we developed a solution that can meet all of the major needs that users were asking us for. And we saw, compared to the market and the competition, that this would allow us to dominate our market, which includes a $4.3 billion US market, where we can sell the product to hospitals, nursing homes, and home care agencies. Where within 5 to 6 years of launching the product on the market, we think we can capture around 6% of that market, yielding over $100 million in sales. And right now, in terms of where we are as a company, we already have a growing pipeline of customers, which includes hospitals and nursing homes who've already contacted us to either purchase a solution or to clinically collaborate. And we've also secured letters of interest from corporate partners. Now, the reason the corporate partners would be interested in us is because when you look at the market, everyone understands that the at-risk population, elderly population, is growing very quickly. And to reduce costs, we need to shift from treatment to the focus on early detection. But a lot of these large corporations have solutions primarily for treatment, nothing really in the early detection space. And most of them sell solutions like the gauze and creams. So they don't actually have the internal expertise to develop the technology, which is important for us to recognize as a company, because it means that they are an ideal strategic partner for us for acquisition in the future, because they can't develop the technology on their own, right? And they're looking for outside tech solutions to bring in internally, right? Even larger companies like Procter & Gamble recognize this growing market and recently evaluated us among 4 companies to be their next billion-dollar brand, with a focus on bringing the solution to the consumer market where people are caring for their loved ones at home. With the mindset of commercializing the solution, I put a team together. I'm the founder and CEO. Dr. Hines, who has his PhD in chemical engineering, develops our custom algorithms, and Michael Schilling supports prototype design and fabrication. We then surrounded ourselves with a team of experts, which includes, most notably, Dr. Joyce Black, who's a current vice president of the National Pressure Entry Advisory Panel. And that's the panel that sets the international and national guidelines for bedsore prevention, care, and management. And so as a team, as we looked at the broader impact of our solution, we realized that really bedsores were really just the beginning. Because our solution could be used to identify the early signs of inflammation in the skin, by applying the same solution to other healthcare conditions, from diabetic foot ulcers to surgical wound monitoring to dermatology, we can increase our market to over $36 billion in a largely untapped skin health and care market, allowing us in the future as a company to either exit through acquisition to one of those strategic partners, or to either exit through IPO. So I thank you guys for your time, and I hope you can join us in reimagining skincare based on data-driven analytics. Just so you guys know, we're currently looking for financing, development partners, clinical sites, and to grow our team if anyone's looking to join our revolution. And in conclusion, coming from a small island with minimal resources, even though I didn't have the resources to invent these solutions in that location, it gave me the spirit of entrepreneurship, it gave me the spirit of creativity, and it put me in an environment where people had to solve their own problems based on scarcity. And I took that with me to America, where I put into my passion, which was medical devices. And with that, it allowed me, by the age of 25, to develop 3 unique medical devices, from robotics to optics to mechanical filtration systems. And so I just want to thank you for your time and the opportunity to be here. And I hope you will be able to join me in doing well while doing good. And thank you. You can guys are
Thank you so much, Dr. Gaspard, for making an inspirational talk. And we will have time for 1 or 2 more questions if anyone has one.
So thank you, Dr. Sanna. That was very inspiring. So tell us about how do you think the entire journey of PhD has ever empowered you in this journey?
That's a great question. I would say it empowered me in 3 ways. It put me around like-minded people. So other people, even though at the time no one was thinking entrepreneurship and translation, in my university, in my department, everyone was thinking fundamental science and publishing. But I was really determined to not just write a thesis that no one would use. I really wanted to make something that could impact healthcare, but it still had me around the people who had a mindset of, let's figure out this problem, let's come up with something new. And then secondly, I would say the second thing was that it put me in an environment that had the resources to allow me to do the work, right? So we had labs, we had prototyping center, you know, there was a hospital down the street that I could go into research at and test the system at. We had an optics lab. So it put me in an environment where, you know, I could ideate and then actually go out and build it and test it, right? That would be very hard outside of the university setting. Yeah, that's very hard. And also very hard outside of like a top university setting, because you need an optics lab, you need an electronics lab, you need a robotics lab, you need, you know, people who have a diversified field of interest who are doing innovative work in those areas. And then thirdly, I would say it supported me on the entrepreneurship side, because the first initial support I got was actually from the university. So they supported me in getting the license, because the inventors get first rights of acquisition. They then also provided some initial funding for me to start. And because I was in a university that also had a business school, I could work with the business school to do the business plan, start competing in business plan competitions, understand what investors were really looking for, that I could make sure my pitch was competitive, and that allowed me to get some initial funding.
Awesome, thank you so much. Thanks, Dr. Gaspard, for the wonderful talk. And on behalf of the planning team for the annual conference, I would like to thank everyone for coming today and for your participation.